Welcome, my devious derivatives. We're going to talk about the derivative of the square root function today, actually the proof of it. So this is something that students ask me a lot. How do you know the square roots of x derivatives is what it is? Or you do know what it is, but you want to prove it. What are the algebraic techniques? What are the tricks of the trade to getting to that derivative? We have f of x equal to the square root of x. And remember the definition of the derivative, f prime of x, or we could even call this df over dx, different notation, means the same thing. It's the limit as h approaches 0 of f of x plus h minus f of x divided by h. So we're going to do that for this function f of x. So this is the limit as h approaches 0. And I'm going to plug x plus h into this function right here. So I get the square root of not x, but x plus h minus regular old f of x. So the square root of x function. I divide all that by h. Now here's where a bunch of people are going to make a bunch of different mistakes. A lot of people are going to subtract the insides of these square roots. Big mistake. We cannot say that the square root of a minus the square root of b is the square root of a minus b. That is a big no-no. Can't do that. Same thing with addition, okay? Some people are going to start squaring things, but remember, we're not solving an equation. We're taking an expression and we're simplifying it. So you can't just start squaring things to get rid of square roots. For example, if I told you that my answer was 3, I had $3 in my pocket. Well, that's also the square root of 9, right? The square root of 9 is 3. But then if I all of a sudden just squared that for some reason, then that would be 9. Because the square root and the square cancel one another. So all of a sudden 3 equals 9. If I have $3 in my pocket, that can't possibly also equal $9. I would like for it to, but it can't. So you cannot just square expressions willy-nilly like this. It just doesn't work. What we're doing is we're taking an expression and we're simplifying it. We are rewriting it to have the same value, but just look different. And then what students will try to do is they plug 0 into the top and bottom here. Well, if I plug 0 in here, I get the square root of x minus the square root of x, which is 0 on top. I get h equals 0 on the bottom. That does me no good either. So the trick is, remember the conjugate from algebra. If we had the square root of a minus the square root of b, then the conjugate of that would be the square root of a plus the square root of b. We're going to change the sign of the second square root right here. And so the trick is multiply by the conjugate. Now here's another very important mathematical concept that I know you all know, but a lot of you may forget that. Okay, so here's that. That's the trick right there, is you multiply by the conjugate. You get the square root of x plus h minus the square root of x. Then you multiply that by the conjugate, which is the square root of x plus h plus the square root of x divided by h. And I know a lot of you are going to get so excited because you remember what the conjugate was that you're just going to go through and do that, and you're not going to get the correct answer. You're not going to get the correct answer because you can't just multiply something by this expression right here. Remember, you can't just square something because you want to get rid of a square root. Same thing is, you can't just multiply something by the square root of x plus h plus the square root of x just because you want to. And you're saying to yourself, but Max, you just told me that's what I want to do. And I left out an important thing here. Okay, you don't just multiply the top by the conjugate. You multiply the top and the bottom. Because remember, we are not solving an equation. We're not trying to balance an equation out. We are taking an expression and trying to rewrite it. Why the top and bottom, and how is that different? Remember, something divided by itself, this thing right here, is equal to what? Something divided by itself is equal to 1. And if I take this thing that I'm working with right here and I multiply it by 1, do I change its value? No, I do not. Right? Multiplying by 1 is nice because it just keeps it the same thing. So again, I'm not changing the value of this thing right here. I'm changing the way it looks. So I get the limit as h approaches 0. Okay? And let's take this nice and slow. The square root of x plus h times the square root of x plus h, that's the square root of x plus h squared, because it's something times itself, right? Here I have plus the square root of x times the square root of x plus h. I'm foiling this out essentially, right? first, and then I just did the outer. The square root of x times the square root of x plus h. I wrote them backwards from how they appear, but we all know the commutative property says it doesn't matter what order you multiply two things in like this. Now I have a minus square root of x times the square root of x plus h. And finally, minus square root of x quantity squared. Okay, because that is a negative times a positive is negative. Square root of x times the square root of x is something times itself. And I divide all that by h. Now I'm not going to go ahead and distribute this h. I could if I wanted to. It's not really going to make that much of a difference right here. So I'll just keep it like that. What does that give me? It gives me two things right off the bat. This and this are opposites. It's something minus itself. That will sum to 0. Here I have the limit as h approaches 0. The square root and the square cancel one another out. I'm left with x plus h. The square root and the square cancel one another out here. I'm left with minus x divided by h times the square root of x plus h plus the square root of x. Again, please resist the temptation to combine these things under the radicals. Can't do it. But what you can do is take x minus x as 0. And so what I have is the limit as h approaches 0 of h on top divided by h times the square root of x plus h plus the square root of x. I didn't write my division bar long enough. But what happens now? You have h divided by h, which, as long as you're not plugging in h equals 0, is 1. And we're not plugging in h equals 0. We are sneaking up on h equals 0, right? We're approaching it. We're computing the limit. And so we are more than welcome to cancel the h from the top and bottom, and we get the limit as h approaches 0 of 1 over the square root of x plus h plus the square root of x on the bottom. Can I plug in h equals 0 now? Yes, I can. I get 1 over the square root of x plus 0 plus the square root of x. X plus 0 is just x, so I get 1 over the square root of x plus the square root of x. Or something plus itself is 2 of that something. I get that right there. So there is the mathematical proof of the square root of x's derivative being 1 over 2 root x.